In a course on differential calculus, you spend the entire term learning how to take derivatives of functions. In a course on integral calculus, you learn how to take integrals. These two processes are essentially inverses of each other, and antiderivatives are the bridge between the two. If you know how to take derivatives, then in theory you'll be able to take an antiderivative. In other words, find the function whose derivative is the function that you're starting with. Let's start with an example. Let's say that we have the function f of x equals 3x squared, and we want to find its antiderivative. What we're really asking then is, what is the function whose derivative is 3x squared? Well, we know that when we take the derivative of a function and end up with an x squared type of expression, then that function must have started out as an x cubed type of function. Not only that, but when you take the derivative of x cubed, you end up with 3x squared. So the antiderivative of 3x squared is just x cubed. To show how these two functions are related, we often say that if f of x is 3x squared, then its antiderivative is capital F of x, and we now know that to be x cubed. So the relationship between these two functions is that the derivative of capital F is little f. And in some textbooks, you'll simply see capital F prime. The derivative of capital F prime is little f of x. When two functions have this kind of relationship, we say that big F of x is the antiderivative of little f of x. There's something we have to be careful of, though. Watch what happens if I take the derivative of f of x, big F of x. If big F of x is x cubed, its derivative is 3x squared. But now let's take a look at what happens if I take the derivative of a different function. Let's call it g of x. What is that function? Well, for the sake of argument, let's say it's x cubed plus 17. Its derivative is still going to be 3x squared. So the antiderivative of 3x squared is not unique. It might be f of x equals x cubed, or it might be g of x equals x cubed plus 17. What's more, it could be actually any function x cubed plus some constant. So when I take the derivative, for example, of h of x, I'm still going to get 3x squared. When we take the antiderivative of a function, 3x squared, we get that its antiderivative is x cubed plus some constant, because taking the derivative of any of the family of functions, x cubed plus c, results in the derivative function 3x squared. Let's do another example. This question asks us to find all the antiderivatives of the function f of x equals 1 over x. What's going to be important moving forward in this class is that you recognize not only how to take a derivative, but what that derivative is and what the function was that gave that derivative. That's really the hard part. So here we're going to have to remember that the derivative of some function is 1 over x if that function is the natural log of x. In other words, an antiderivative of 1 over x is ln of x, because the derivative of ln of x is 1 over x. But remember, the derivative of ln of x plus the square root of 17, for example, is also 1 over x. So the antiderivative of 1 over x is actually a family of functions, the natural log of x plus some constant. That constant might be a 1, it might be a 17, it might be a square root of 3. It could even be pi. It can actually also be 0. In other words, one of the antiderivatives of 1 over x is just ln of x. But it's only one of an infinite number of possible antiderivatives. So we have to say plus c whenever we're taking an antiderivative in order to capture all of the possible solutions. Are you ready to try one yourself? Find all the antiderivatives of the function f of x equals the sine of x. Remember that in order to answer this question, you need to ask yourself, what is the function whose derivative is the sine of x? There's an infinite number of these. Whatever the answer is, could have some constant tacked on to the end of it. And the answer when you took the derivative of big F of x would still be the sine of x. See if you can figure out now what that function is. Whose derivative is the sine of x? Did you figure it out? The derivative of cosine of x is negative sine of x. You could think of negative sine of x as negative 1 times the sine of x. Likewise, you can think of negative cosine as negative 1 times the cosine. So if you take the derivative of the negative cosine of x, you're going to get negative the sine of x. So the antiderivative of sine of x is negative cosine, but all the antiderivatives of sine of x are negative cosine of x plus a constant.